Hello, today is a new day. Welcome back to St. Daniel's Quicksolve Science class. Okay, today we have another wire question on the board. Let's break it down. The question says, a swimmer of mass 48 kg uses her legs to push herself away from a swimming pool wall, applying a force of 280 newtons. The water that the swimmer accelerates through applies 160 newtons of force in the opposite direction to that in which she accelerates. What is the swimmer's acceleration through the water? Okay, so this is a simple wire question. As usual, I have to read it, understand it, you write down all the vital information before you start to solve. So let's solve it. So let's find out all the keywords. So a swimmer of mass 48 kg. So this means that the mass of the swimmer is 48 kilograms. The solution. So mass of the swimmer is 48 kilograms. Uses her legs to push herself away from a swimming pool wall, applying a force of 280 newtons. So the force that the swimmer is applying is 280 newtons. So swimmer's force is 280 newtons. The water that the swimmer accelerates through applies 160 newton of force. So this is the opposing force of the water, which is 160 newtons. So the opposing force of the water is 160 newtons. Again, 160 newtons of force in the opposite direction to that in which she accelerates. What is the swimmer's acceleration through the water? So we are asked to calculate the swimmer's acceleration through the water. So acceleration becomes question mark, but that is what we are going to look out for. So let's solve it with ease. Okay, so before we can solve this, we have two forces. We have the swimmer's force, which is 280 newtons, and then we have the opposing force of the water, which is 160 newtons. And then we cannot use all the two forces to solve it. We have to get only one force, and that one is called the net force. So let's find the net force from the question. So net force, the net force, we are going to subtract the bigger force from the smaller one. That gives us the net force. So the bigger force is the swimmer's force. So net force will be swimmer's force minus opposing force. That is the opposing force of the water. So this gives us swimmer's force, which is 280 newtons from the question. So 280 newtons minus the opposing force of the water, which is 160 newtons. 160 newtons. So 280 minus 160 give us 120 newtons. So the net force is 120 newtons. So this is the force we are going to use to calculate the question. Okay, so the question says we should calculate the acceleration of the swimmer through the water. Okay, so we know that from Newton's second law, force equals mass times acceleration. So we can make acceleration from that formula. Therefore, force equals mass times acceleration from Newton's second law. Then we are making acceleration the subject because the question said we should find acceleration. So we can divide here by mass. The same thing here, divide here by mass. Therefore, mass cancels mass. Then we get acceleration to be equal to force over mass. So this is the formula we can use to calculate the acceleration of the swimmer through the water. Acceleration equals force over mass. So let's substitute the information into the formula and find our acceleration. So acceleration will be equal to, so from the question, the force, that is the net force, which is 120 newtons. So this gives us 120 newtons divided by mass from the question. The mass of the swimmer is 48 kilograms. So out of 48 kilograms. Now let's cancel out and get our answer. So to cancel this, you can find from mathematics, you can find the highest common factor of 120 and 48. And then the highest common factor of 120 and 48 is 24. So 24 can divide 48, which give us 2. And then it can also divide 120 to give us 5. So the final answer is acceleration will be equal to 5 out of 2. So changing this one to decimal give us acceleration to be equal to 2.5. And acceleration is measured in meters per second squared. Thank you. If you found this useful, like, subscribe, and comment for the next episode.